to assist you in the proper operation of your tractor and its options. This videotape includes the 8000 Series Tractor Video Operator's Manual and the Video Operator's Guide for the RoadTrack Guidance System.
They are easily adjusted side to side to accommodate various row spacings, crop heights, or attachments. And there is a compartment under the cab entry platform for your convenience. This wide door provides easy entry into a spacious cab, designed so that all controls are within easy reach. This 3-position damping lever should be moved to the rear to firm the ride or forward to soften the ride. Fore and aft and side-to-side movement of the seat is damped with hydraulic shock absorbers to improve the ride in rough terrain. To allow fore and aft movement, pull up on this handle or push it down to lock out movement. To allow side-to-side movement, pull up on this handle. Lock it out by pushing down on it. Lift this handle on the right side of the seat to slide the seat forward or back to the position you want. On the left armrest is the seat height adjustment switch. With the tractor key switch in the on position, you can use this rocker switch to raise or lower the seat. It will then remember this setting until you change it. The seat may also be swiveled 20 degrees to the right or 15 degrees to the left. Just pull up on the handle to make your adjustment. Push down on the handle to lock out the adjustment. And directly behind the command arm are 2 more seat adjustment controls. Use this one to adjust the angle of the backrest, and this one to adjust the firmness of the seat's lumbar support. The 8000 Series tractors have a unique new feature, the command arm. All of the primary tractor operation controls have been placed here for the operator's convenience. And the command arm also includes a handy storage compartment for your convenience. If you purchased the optional Deluxe Command View cab, the position of the command arm may be adjusted for precise operator comfort. And finally, the left armrest may be raised or lowered to the desired position with the press of a button. After you have the seat adjusted to your satisfaction, be sure to fasten your seat belt. Remember that for your maximum protection, you should always wear a seat belt whenever operating this tractor, since it is equipped with rollover protection. The steering wheel on 8000 Series tractors can also be adjusted. It can be raised and lowered, and telescoped in or out. Once you have the wheel adjusted to a comfortable position, it will remember that position. So you can use this handy foot release to raise the steering column out of the way when you exit the cab. Then, When you return to the cab, step on the foot release and the wheel will return to your exact setting. On the upper front section of the control console are the air quality controls. This rotary control is used to adjust the temperature of the air, and this switch controls the fan speeds. The rocker switch is used to turn on the air conditioning when it is needed. On the left side of the front console is the airflow direction knob. You can use it to direct the flow only to the windshield for defrost, or to both you and the windshield. The Command View cab has some special features to help you keep cool, including a storage area for a cooler, with a bump stop built into the floor mat to keep it from sliding forward. And the air quality system vent has a built-in can holder that's designed to keep your drink cold once it's been opened. Finally, if you have a deluxe Command View cab, there will be a special storage drawer located underneath the operator's seat. The 8000 series tractor has two instrument modules. This module, located on the right console, is known as the vehicle monitor. And this is called the corner post display. The corner post display has LCD readouts for ground speed, the gear that has been selected, and the engine RPM. The vehicle monitor on the right console features analog gauges for engine water temperature and fuel. And if you purchased the optional Deluxe Command View cab, the monitor will include an engine oil pressure gauge. The vehicle monitor monitors the engine, transmission, electrical and hydraulic functions of the tractor. If a malfunction should occur, a warning light will illuminate at the top of the panel, either Stop Engine, Service Alert, or Information. The stop engine and service alert signal lights are duplicated on the corner post display to make sure you don't miss seeing them. If the stop warning light comes on, shut the tractor down immediately. It means that immediate attention is required to correct the problem before the tractor may be operated. If the stop warning light comes on, the vehicle monitor will also display a light showing which system has a problem. The service alert light means that the tractor needs attention as soon as possible to ensure continued proper operation. Again, the vehicle monitor will display a signal light indicating what service needs to be performed. When the information light comes on, the system has detected a problem that could reduce the performance of your tractor. Although the tractor is still operational, you should deal with the problem at your earliest convenience. To find out what the problem is, press the # key on the keypad, and the LCD to the left of the keypad will display a code. Be sure to record this code for future reference. You should then check the code you recorded against those listed in the operator's manual. Possible solutions for the problem are next to the codes in the listing. These codes are especially helpful if the problem should require a service technician to correct it. You can then clear the diagnostic code from the display by holding down the # key for 7 seconds. This will also turn off the information light. The vehicle monitor display also can be used to get readouts on the 6 functions shown on the keypad to the right of the display window. They are percent of wheel slip, ground speed, PTO speed, distance traveled, the diagnostic codes you were just shown, and service hours. To view any of these, just press the appropriate touch switch and watch the display. Keep in mind that the percent of wheel slip will only function if the tractor is equipped with optional radar. If radar is not installed, ground speed will be calculated based on wheel speed. This will not be true ground speed. Again, be sure to read your operator's manual thoroughly to get all of the information you will need for safe operation. Let's take a moment to point out the primary controls for the 8000 series tractors. As we mentioned earlier, all of the primary controls are built into the command arm for convenience of operation. They include the throttle, transmission shift lever, hitch raise-lower switch, hitch controller, selective control levers, PTO switch, and in the storage compartment are control knobs to adjust hitch height, rate of drop, and draft sensitivity. Now, let's look at the procedure for startup. First, always make sure that everyone is clear of the tractor and any attached implement. The transmission should be in park, and the hitch in the lowered position. If you attempt to start the tractor with the transmission in gear, a special safety device will prevent the starter from engaging. So, to start the tractor, you must move the lever to park or neutral, and make sure that the PTO is disengaged. Set the hand throttle at the low idle position. Turn the key switch to the first position and check to make sure that all indicator lights illuminate. They will stay on about 2 seconds. Continue turning the key until the starter is engaged and the engine starts. Your tractor is also equipped with a starting aid for use in cold weather. For more detail, please refer to your operator's manual. The 16-speed power shift transmission is standard on all 8000 series tractors. It has 16 forward gears and 4 reverse gears. Clutching isn't needed between forward or reverse gears, and shuttle shifting between forward and reverse is modulated and requires no clutching. Since this transmission is all new, we feel it's important to familiarize you with its special features and benefits. We'll begin by giving you an overview of the transmission and its controls. Next, we'll show you driving techniques to acquaint yourself with transmission shifting. Then, we'll show you some of the special features of the power shift. And finally, we'll cover the operating characteristics of the tractor so you'll know what to expect in normal day-to-day conditions. The 8000 series power shift transmission is electronically controlled and hydraulically actuated. It has 16 forward gears ranging in speed from 1.5 to nearly 24 miles per hour. There are 4 slow speeds in the PTO harvesting working range, 8 mid-range speeds for field work, and 4 faster speeds in the transport range. There are 4 reverse gears with speeds ranging from 1.2 to over 6 miles per hour. You operate the transmission with this convenient control lever located on the command arm module. Just remember that when increasing speeds either in forward or reverse, move the lever in the direction of travel. When increasing speeds in forward, push the lever forward. To increase speeds in reverse, pull the lever to the rear. The selected gear is displayed on the corner post display. Shifting from one forward or reverse gear to another can be done in 2 ways: holding or bumping. When you hold the control lever, shifts will automatically be made 1 gear at a time. When you bump the lever, the transmission controller keeps track of the number of bumps and stops shifting when the commanded gear is reached. Bump shifting is a much quicker way to get your tractor up to transport speed than holding. When the transmission shift lever is in park, the corner post display shows P. Do not shift the transmission into park until the tractor has come to a complete stop. If the shift lever is moved to park, or the engine is shut off, while the tractor is moving, the tractor will abruptly stop forward motion when ground speed drops below 2.5 miles per hour. When the control lever is moved to neutral, the park brake will release, and the monitor will display the pre-selected forward gear and the letter N for neutral. However, the transmission itself will remain in neutral when the lever is anywhere in the neutral slot. When the shift lever is placed in the forward or reverse slot, the display will show a corresponding F or R along with the commanded gear. With the clutch pedal released, the tractor will begin moving as soon as the lever is moved into the slot. 8000 series tractors have an operator's presence safety device built into the seat. This device prevents the transmission from shifting into gear unless the operator is in the seat, and assures that you are in a position to control your tractor before it can be moved. Now for a drive sequence to acquaint you with what this transmission can do for you. Before you put your tractor to work, we encourage you to test drive your investment, utilizing the shifting techniques to follow. Taking time for a test drive will give you a feel for how your power shift will operate and will eliminate any surprises later. All tractors are programmed at the factory so that at engine startup, when the control lever is placed in the forward slot, the transmission will automatically go to 7th gear and to 2nd gear in reverse. The programmed forward gear can be changed from 7th forward to either 5th or 9th forward if you so desire. Contact your John Deere dealer for more details. Once the tractor is started, you can pre-select another gear up to 13 forward or 3rd in reverse. On early 8000 series tractors, 11th gear was the highest forward gear that could be pre-selected. To pre-select a forward gear, depress the clutch pedal and bump the control lever to select the desired gear. Then move the lever to neutral and release the clutch pedal. Now you're ready to go. The transmission will shift directly to the pre-selected gear when you move the control lever into either the forward or the reverse slot. The transmission will stay in that pre-selected gear until you choose a new gear or restart the tractor. When shifting from reverse, the highest forward gear the transmission will automatically shift to is 11th. For example, if you are in 13th gear and shift to reverse, and then shift back to forward, the transmission will automatically shift to 11th gear. However, say you are in 13th gear or higher, and you stop the tractor using the clutch pedal or shifting to neutral, but don't go through reverse. Then, when you shift to forward again, the transmission will be in 13th gear. If you start out in 13th gear with a heavy load and the clutch slips excessively, the corner post will display a caution light warning. This warning means a lower gear is recommended for this particular load, and you should downshift. If you don't downshift and the transmission detects too much heat, it will then automatically shift down from 13th to 11th gear, and the control console will display a flashing symbol and an information light warning. This key performance feature protects the clutch from overheating. While the clutch isn't needed to start or stop your tractor, at times you will find it useful as an inching pedal. Using the heel of your foot as a pivot point will give you maximum control of the clutch pedal. And using a higher reverse gear at low RPM will improve inching capability. Examples would include operating in confined areas, hooking up implements, or during stops when maximum operator control is needed. Now, let's take a look at the special operating features of the 16-speed power shift transmission. When you want to get up to transport speeds quickly, bump the shift lever rapidly. If you should desire, however, you can cancel any remaining shifts by bumping the shift lever once in the opposite direction. For example, you bump shifted up to 15th gear, but once the tractor reached 12th, you decided to stop the upshifting. Just bump the gear shift lever once in the opposite direction, and the transmission will stop shifting and operate at the gear it's in. The The transmission can rapid shift from first gear through 13th gear without hesitation on the way to the gear you commanded. This is a change from early model 8000 series tractors. When rapid shifting between 5th and 12th gears, the transmission will skip gears to get to the commanded gear more quickly, regardless of the load on the tractor. For example, if you are in an odd-numbered gear, such as 5th, and quickly bump up to 11th, the transmission will start out in 5th gear, then shift to 7th, then 9th, and then 11th, skipping every other gear. Keep in mind the transmission will only skip gears in the 5 to 12 gear range. Shifts between 1st gear and 4th gear are made one at a time, quickly, regardless of load. Shifts between 13th and 16th gear are based on wheel speed. Suppose you are in 13th gear and quickly bump shift to 16th. The transmission will sequentially shift from one gear to the next when ground speed is high enough for the engine to handle the load the higher gear requires. These shifts take place faster than on early model 8000 tractors. Another convenient feature automatically matches the gear to the ground speed of your tractor. For example, you are transporting in a gear higher than 13th. And you want to slow down momentarily to make a turn by depressing the clutch pedal. When you release the clutch pedal, the transmission has automatically shifted down to a gear that matches the ground speed of the tractor, as low as 13th gear, but not lower. In fact, the transmission won't shift below 13th even if the tractor comes to a complete stop. This allows the tractor the capability of quickly recovering transport speeds. On early 8000 series tractors, the speed matching gear was 11th forward. The same is true in reverse. If you are backing up in 4th gear and depress the clutch pedal, and the tractor slows down to 3rd gear speed, the transmission has automatically shifted to 3rd gear when you release the clutch pedal, even if the tractor has come to a complete stop. Now, we want to familiarize you with some of the operational characteristics of the transmission and its electronic controls. Changing from one forward gear to another requires disengaging and engaging different clutches inside the transmission. Sometimes, changing gears requires multiple clutch changes within the transmission to accomplish the shift the operator has commanded. When these multiple clutch shifts are made, they will be more noticeable than the single clutch shifts. Examples of gear changes affected by multiple clutch changes are 4th to 5th gear, and 5th to 4th gear, and 12th to 13th, or 13th to 12th. Think of these shifts as being similar to a range shift in a manual transmission. As you probably know, a range shift feels different than other shifts. Transmission oil temperature also can affect shift quality. To check transmission oil temperature, press the service hours and PTO speed keypads on the control console simultaneously. Oil temperature will be displayed in centigrade. The best quality shifts will occur when transmission oil temperature is above 30 degrees centigrade. Your power shift transmission will perform best with John Deere oil because our electronic controls adjust to viscosity changes based on our oil specifications. Although there are other good quality oils on the market, using them could cause a deterioration in shift quality, most noticeably with cold oil. See your John Deere dealer for details on transmission maintenance. Over time, some transmission shifts may become more noticeable than when your tractor was new. Again, your dealer technicians have the ability to recalibrate your power shift transmission to keep it operating at peak performance. When operating in reverse, engine RPM is adjusted to achieve speed changes between some gears. Engine RPM increases by 200 when the transmission shifts from 2nd reverse to 3rd reverse gear. And when operating at full throttle, RPM decreases from 2400 to 1600 when a shift from 3rd to 4th reverse gear is made. Because the engine RPM is reduced in 4th reverse, you cannot operate the PTO in that gear. In other words, if you are operating in third reverse with the power takeoff engaged and try to shift to fourth reverse gear, the transmission will not allow the shift. Or, if you are operating in fourth reverse and try to engage the power takeoff, the transmission controls won't allow engagement. Engine RPM changes between reverse speeds where necessary to obtain nicely spaced speed changes. Your dealer technician has the capability to program the control unit on your tractor so that engine RPM will not change between second and third reverse. This is especially helpful if you operate the PTO equipment in reverse gears. See your dealer for more information. .8000 series transmissions are equipped with a spring-engaged park brake. If towing the tractor is necessary, the transmission park brake must first be released. Again, please refer to your operator's manual for complete information on park brake release and towing your tractor. Here's a helpful tip to get your tractor up to transport speeds more quickly. Use the clutch when upshifting. An example would be if you are pulling out of a driveway in 5th gear and want to get the tractor up to 16th gear quickly. Just depress the clutch pedal and quickly bump the shift lever up to 13th gear. When the clutch is released, the transmission will shift directly to 13th and skip all the intermediate gears. Once the tractor starts moving in 13th gear, bump the lever up to 16th. Here's another tip you can use when shifting to a forward gear from reverse to take advantage of the slight delay before the transmission goes into gear. Let's say you reach the end of your field in 10th gear and there is no headland for turnaround. Depress the clutch pedal and stop the tractor. Shift to reverse and back up. After you've backed up far enough to make your turn, shift to forward without clutching. The delay time before the tractor goes into gear will allow you to bump the gear down from the previous 10th gear to, say, 6th gear for a smooth, controlled start. Here's still another tip that is especially useful when slowing down at the end of a row. Just bump the shift lever twice, and the transmission will skip a gear. Once you've completed your headland turn, just bump the shift lever twice to shift back up to gear. Electronic controls give us the ability to incorporate many onboard diagnostic and safety features that other transmissions don't offer. These diagnostics help our dealer technicians identify many problems that used to require teardown. The bottom line? Time and money savings for you. If you have a flashing transmission light on your vehicle monitor along with a flashing information light, simply select the touchpad with the pound symbol on it. Next, check the readout to the left of the touchpad for the diagnostic code. Then, check the code number in the operator's manual. The manual will provide you information about the problem and a possible solution. This information is especially helpful if the problem should require a service technician to correct it. To clear the code and turn off the information light, push and hold the touchpad for 7 seconds. This concludes our transmission section. If you have any questions, contact your John Deere dealer for more information. As you know, tractors equipped with mechanical front-wheel drive have greatly increased traction, but the 8000 series offers even more. The new design makes these tractors the most maneuverable MFWD tractors in the industry. Watch the unusually tight turning radius, even with these narrow tread settings. To engage the drive, use this rocker switch on the control console. The switch has 3 positions: on, brake assist, and automatic. A light on the vehicle monitor illuminates when it is engaged. When the switch is in the on position, the MFWD is engaged at all times. Because of this, the switch should never be on during transport, since it can greatly increase wear on the tires. If the switch is in the auto position, the MFWD will disengage if you apply either brake, such as in tight turns. In auto mode, the MFWD will disengage whenever the ground speed goes over 11.8 miles per hour. This helps to extend tire life during transport. This is a change from early model 8000 series tractors to allow higher field operating speeds with MFWD engaged. At maximum engine throttle, the mechanical front-wheel drive will disengage between 13th gear and 14th gear when it is in the auto mode. When the MFWD turns off, you will feel the clutch gear disengage. This will sound and feel something like a gear change in the transmission, but it is actually the MFWD clutch disengaging. The drive will re-engage anytime both brakes are applied. This feature gives you four-wheel braking. This feature also applies to the brake assist position. Brake assist, or off, is used when the operator wants the MFWD to remain off, such as when transporting or when under light load conditions. Mechanical front-wheel drive can be engaged and disengaged in all gears, in either forward or reverse, during operation and under full load. Another feature that helps maintain traction is the differential lock. It is meant to be used when one rear wheel starts to spin. To engage it, depress this foot switch located between the clutch and brake pedals. Here's a note of caution. When the differential lock is engaged, it may be difficult to turn the tractor. For this reason, the differential lock will automatically disengage at speeds above 9 miles per hour. To manually disengage the lock when it's not needed, simply depress either brake pedal. The 8000 series also features field cruise control, which allows the tractor to maintain a constant ground speed. This is especially important when precise ground speeds must be maintained for planting or dispensing of chemicals. Here's how it works. Push the engine throttle all the way forward and turn the field cruise control switch counterclockwise to the click detent position. This sets the engine speed at 2200 RPM. You can adjust your John Deere field cruise control anywhere between 1450 and 2200 RPM. Be sure to refer to your tractor operator manual for more details. This is the multifunction hitch controller, designed to provide you with a high level of convenience and ease of operation. Both the command lever and the lever stop can be easily operated with one hand. The stop enables you to set the travel limit of the command lever. To change the stop position, simply push down on the knob and rotate it until you have the desired position set. To hook up to an implement, first make sure the area is clear and then slowly back toward it until the hitch is in position. To eliminate undesired hitch movements during hookup to an implement, turn the low depth mix knob counterclockwise all the way to the click detent position. This setting is position control. Using the hitch command lever, slowly raise the hitch until the implement can be secured at each attaching point on the quick coupler. Be sure to lock all of the latches securely. The external remote switch can also be used if you are making the hookup from the ground. You will notice that the hitch moves much slower when you are using the remote. This provides you with an additional level of safety. And when you are using this switch, the command lever in the cab is locked out to prevent anyone from accidentally overriding the remote switch. When you complete your adjustment, simply release the switch and it will automatically go back to the neutral locked position. The raise limit knob is located in the command arm compartment. When fully clockwise, the hitch can be raised to the maximum height. Also, under the cover is the rate of drop adjustment. Turn it clockwise to increase and counterclockwise to decrease the rate of drop. Keep in mind that the hitch will drop faster with heavier implements, So always use caution when you are making these adjustments. Fully lowering the implement should take at least 2 seconds. Excessive drop speed may cause damage. Our next hitch control is the load depth mix knob. Once you are in the field, it is quite likely that you will want to adjust the load depth mix, varying the mix of position and draft control. The setting chosen will depend on soil and terrain variations, as well as the implement you are using. A higher number will make the hitch more responsive to changes in draft load. For less hitch response, select a lower number. Once you have the hitch set to the desired depth, you can use the raise lower switch on the command arm to raise and lower the hitch during headland turns. And finally, always have the hitch command lever in the raised, locked position when transporting. Deere 8000 series tractors feature state-of-the-art John Deere pressure and flow compensating hydraulics with our exclusive electro-hydraulic selective control valves. Up to 5 SCVs can be used on 8000 series tractors. Connecting hydraulic lines is quick and easy. Simply push them into the couplers. To remove them, use the easy release lever. Both hoses are released simultaneously. Single or multiple motor return kits are available as field-installed options for operating hydraulic motors. Refer to your operator's manual for information regarding hydraulic motor hookup. The SCVs are operated from the command arm using these control levers. The 3 levers at the front of the arm operate the 3 SCV valves on all 8000 tractors. If a 4th SCV control lever is installed, it will be mounted at the center of the command arm. And this 5th lever may be field installed. The operation of these controls are very similar to previous conventional levers. The SCV levers have 6 different operational positions. The center position, which is neutral. Mid-range extend and retract. Detent extend and retract. And float. The oil flow rate and detent times are easily adjusted with these touch pads and control knobs on the touch set control panel. To adjust the flow rate, select the SCV to be adjusted and rotate the knob clockwise to increase flow and counterclockwise to decrease it. Notice that the display will move between the turtle and the rabbit as you adjust the flow. At the left end of the window is a reading between 0 and 10. This digital readout is an indicator that shows how much of the available oil flow is being used. The electronic detent time release function has 3 mode settings that can be selected. The first setting is 0 seconds, no detent. The second is adjustable from 1 to 19 seconds, and the third is continuous flow. A timed release detent should be selected when you want oil flow to stop when the cylinder has reached the full extend or retract position. The amount of time that the flow of oil needs to continue varies depending on the cylinder size. Larger cylinders require more oil volume and time to fill. To program timed detent, select the SCV you want with the touchpad. Then, rotate the knob to set it to the desired number of seconds between 1 and 19. Once you have selected and programmed the time in, the oil flow to that SCV will stop when that time expires. The lever will automatically return to the neutral position when it is released, but oil flow will continue until the time setting expires. No detent, or 0, means that oil flow will start or stop when the lever is released or engaged. To set detent to 0, first touch the keypad that corresponds to the SCV you will be using. Then, turn the time control knob counterclockwise all the way to 0. The time setting you have chosen, 0 seconds, will appear in the LCD window under the touchpad you selected. The hydraulic oil flow will now start or stop whenever the SCV lever is engaged or disengaged. Continuous detent is used for hydraulic motors or applications where a continuous flow of oil is required. To set detent to continuous, select the touchpad for the SCV. Then, turn the knob clockwise all the way to C. The window below the touchpad will show that time equals C. The hydraulic oil flow will now continue until it is manually disengaged or the engine is shut off. To cancel oil flow, move the control lever until the valve cancels. This is a change from early 8000 series tractors, where lever operation was more sensitive and the lever could accidentally be bumped out of continuous operation. Rotating the detent adjust knob from continuous to timed detent and then back to continuous won't cancel oil flow to the vacuum motor. This is also a change from early model 8000 series tractors. To use the float position, push the lever forward and then down. The SCV will now stay in float until the lever is manually moved out of the float position. You'll see a wavy line on the monitor to indicate the float position. Here are two extremely important safety points you should always keep in mind when transporting an implement hooked to an SCV. Be sure to engage the transport lock by touching the transport lock touchpad. This will eliminate the chance of accidentally lowering the implement by touching one of the SCV levers. Then, when you arrive at your destination, unlock the controls by touching the pad again. However, the transport lock does not take the place of transport locks provided with the implement. Both locks should be used when transporting. Safety is always first. Some implements can be equipped with a position sensing device that enables you to set upper and lower limits for electro-hydraulic depth control. You can adjust the depth of the implement according to load conditions while you are on the go. When using electro-hydraulic depth control, the hydraulic hoses must be hooked to the number 1 SCV and the retract extend hoses must be hooked up correctly. If you try to raise the implement and nothing happens, the hoses are switched and the sensing device will not allow operation. The implement should raise when the SCV lever is pulled toward you and lower when it is pushed away from you. A 9-pin electrical connector is required to operate the electro-hydraulic depth control. When the 9-pin connector from the implement is connected to the module, it sends a signal to the touch set control panel telling it that it is connected. Remember that the key switch should be off when the connection is made. A letter P appears in the window under the first SCV touchpad, indicating that the connection has been made. To set the operating depth of the implement, use the number 1 lever to lower it and touch the lower set touchpad on the touch set control panel. To set the height of the implement, raise it to the desired level and touch the upper set touchpad with the extended cylinder on it. A symbol showing where the upper and lower settings have been made will be displayed in the left side of the touch set control window. With the settings now made, simply pull the SCV lever to the detent position to raise it. Or, to lower it, push the lever to the detent position to release it. If you later decide that the upper or lower settings need to be changed, it is possible to bypass the present settings. Simply pull or push and hold the lever until you reach the desired height or depth, and then touch the upper or lower touchpad to reset the limit. For your safety, the 8000 series tractors have an operator presence switch built into the seat. If you should get out of the seat while an SCV lever is engaged, an alarm will sound and a light will flash on the vehicle monitor. This is the power takeoff switch located on the command arm. Power takeoff modulation is selectable on 8000 series tractors. It can be set for maximum modulation or minimum modulation. Tractors shipped from the factory are programmed for maximum modulation. Both modulation settings will handle either light or heavy PTO loads. On early 8000 series tractors, PTO clutch modulation was not selectable. Your dealer technician can change the power takeoff modulation from maximum to minimum by simply entering the diagnostic mode and changing the program value in the controller. 8000 series tractors are equipped with a standard 1 3/4 inch 1000 RPM PTO or an optional 1 3/8 inch 540 or 1000 RPM PTO with a 1 3/4 inch stub shaft. High horsepower tractors, like your new 8000, are not usually equipped with a 540 RPM power takeoff because 540 RPM implements aren't built to handle that much horsepower. The optional 540 and 1000 RPM 1 3/8 inch PTO is designed for implements that require less than full tractor power. So, to protect the PTO shaft on your tractor, the 1 3/8 inch combination 540 and 1000 RPM PTO shaft has a torque limiting collar mounted on it. This collar is designed to limit damage to the PTO shaft. So if your torque limiting collar fails, it means that your tractor is running too much horsepower through the shaft, and you should either use the 1 3/4 inch shaft or lighten the load. If your tractor is equipped with the combination 540 and 1000 RPM 1 3/8 inch power takeoff, you can change the speed by reversing the adapter. Please keep in mind that this shaft is designed only for implements requiring less than full tractor power. First, remove these 4 cap screws. The shaft operates in a dry compartment, so no oil will run out when the shaft is removed. Pull the shaft out and remove the torque limiting collar. Reverse the shaft and install the collar on the end of the shaft being inserted into the housing. Reinstall the shaft and secure it with the cap screws. If your tractor has the 1 3/4 inch 1000 RPM PTO used for full load operations, it will not have a torque limiting collar. To remove this shaft, simply remove the snap ring and pull the shaft out. To engage the PTO, push down and forward on the PTO switch. The indicator light will illuminate on the vehicle monitor, and the speed readout will be displayed. To disengage the PTO, simply pull the switch back. Again, the operator presence system we described for the SCVs comes into play. If you should get out of the seat while the PTO is engaged, an alarm will sound and a light will flash on the vehicle monitor. For more details, please consult your operator's manual. Now that you have your new 8000 series tractor, you should ballast it to achieve the best performance for your operation. Properly ballasting your tractor can make a tremendous difference in overall performance, fuel economy, and soil compaction. All 8000 series tractors are shipped with a book entitled Optimizing Your 8000 Series Tractor for Top Performance. This book is located in the pocket behind the seat, along with the operator's manual. Use this book when ballasting your tractor. To achieve the best possible performance from your new 8000 series tractor, follow these simple rules. 1. Ballast the tractor correctly for your operation. 2. Correctly adjust tire inflation pressure. Let's discuss these important steps individually. The first step is ballasting the tractor. Normally, 8000 series tractors should be ballasted between 120 to 145 pounds per PTO horsepower. 130 pounds will be most common. Tractors also should have the correct balance or weight split between the front and the rear for the operation that is being performed. Mechanical front-wheel drive tractor weight splits should be front 35%, rear 65%. Heavy hitch-mounted implements may require a higher percentage of front weight. For mechanical front-wheel drive tractors, it is critical for power hop control to make sure the front weight is no more than 35% of the total tractor weight. A typical unballasted 8000 series MFWD tractor with dual rear wheel equipment has approximately 37% of its total weight on the front axle. To achieve a 35% weight split, weight first needs to be added to the rear of the tractor. This is different than on older model tractors, where front weight was added first. 8000 series tractors have approximately 1,250 pounds more starting weight on the front than the models they replace, so they won't require as many front weights. For a typical 8100 tractor, equipped with mechanical front-wheel drive, no additional weight should be required. An 8200 MFWD tractor, ballasted at 130 pounds per PTO horsepower, would need a front weight support with no front weights, and 2,130 pounds of cast weight on the rear of the tractor. This combination will give the tractor the correct weight and balance. An 8300 MFWD tractor, ballasted at 130 pounds, would need a front weight support with 8 front weights and 3,930 pounds of cast weight on the rear of the tractor to achieve the correct weight and balance. The factory recommendation for 8400 tractors is a front weight support with 12 front weights and 5,130 pounds of cast weight on the rear of the tractor. The recommendations we've just talked about are starting points. More or less ballast may be required for your operation. And again, these recommendations are for towed and hitch-mounted implements. Some heavy hitch-mounted implements may require more front weight. Any front weight added for hitch-mounted implements should be removed when operating with towed implements. For two-wheel drive tractors, the weight split recommendations are: for towed implements, 25% front and 75% rear. And for semi-integral implements, 30% front and 70% rear. And finally, for hitch-mounted implements, 35% front and 65% rear. When adding ballast to the rear of the tractor, cast weight is preferred. Liquid ballast will stiffen the tires, causing the tractor to ride rough and contribute to power hop. The factory provides a choice of 1,500 or 450 pound weights for cast drive wheels, and 165 and 450 pound weights for steel dual wheels. The 165 pound weight must be attached to the wheel before another weight can be added. Liquid ballast in the front tires may be required for additional weight or to stiffen the tire for power hop control. For effective control of power hop on MFWD tractors, the tractor needs stiff front tires and soft rear tires. That's why liquid is not recommended in the rear tires. If liquid is used in the rear tires, a maximum 40% fill is recommended. All tires on the axle should receive the same amount of fill. The final step to optimum performance is to adjust tire inflation pressure. Tire manufacturers recommend dual tire inflation pressures as low as 6 pounds per square inch. As long as these are the correct pressures for the load on the axle, tire manufacturers will stand behind their recommendations. Use the Optimizing Performance book to calculate the axle weight of your tractor, and then adjust your pressures accordingly. Properly adjusting the inflation pressure in your tires is important to the performance of the tractor. If power hop occurs after following these steps regarding ballasting and inflation pressures, raise the front tire inflation pressure in 2 psi increments until it stops, to a maximum of 30 psi for 2-star or 36 psi for 3-star tires. Make sure rear tire pressure is adjusted to the minimum required for the axle load of the tractor. This step is very important. Now, take the tractor for a test drive. In some extreme cases, raising front tire pressure may not cure power hop. If this is the case with your tractor, use up to 75% liquid fill in the front tires and remove an equal amount of front ballast. The 8000 Series Command View cab has 5 locations for mounting implement monitors. 1 on the front post, 2 behind the right-hand console, and 2 on the rear post. Installation is easy. Simply remove the protective cap from the threaded bosses and bolt up the bracket. There are 2 grommets in the rear of the cab. They can be easily removed for installation of the wiring harness. The grommets can be cut to fit a particular harness and then should stay with that harness. A new grommet can be purchased from your dealer to cover the access hole after the implement harness is removed. There is 1 standard electrical convenience outlet on the rear console of the standard Command View cab. And there's an additional outlet on the Deluxe Command View cab. This outlet can be field installed. These 3-pin connectors supply ground, live 12 volts, and key switched 12 volts. All daily maintenance, including fuel fill, can be done from ground level on your new tractor. The engine oil level should be checked daily. You can check and fill from this single convenient location. The hydraulic oil level is easily checked with this sight gauge at the rear of the tractor. And don't forget to check the engine coolant level. To clean or replace your cab filter, remove the cover and pull the filter out. To clean or replace the engine air filter, simply remove the cover and pull the element out. When cleaning the filter, be very careful not to damage the ends so they will seal properly when you reinstall it. And finally, check your tires closely for excessive or unusual wear, breaks, or cuts. In addition to daily maintenance, it's very important that periodic maintenance is also performed as outlined in your operator's manual. Remember, proper servicing is just as important as proper operation to the productivity, safety, and reliability of your new
Road Track Guidance from John Deere. One more step in our continuing commitment to providing you with fully integrated farming systems to meet your every need. To begin with, we want you to know that we sincerely appreciate your business and feel you will find that our new row guidance system will more than meet your expectations. We have produced this videotape to acquaint you with Road Track, its features, benefits, and operations. However, please keep in mind that this program is intended to be used only as an orientation, not as an operator's manual. You should always refer to the manual itself for any questions you may have about detailed use of the system. And of course, your first step should always be to make sure that you fully understand all safety precautions for your tractor and the Road Track guidance system. Your safety always comes first. The John Deere Row Track Guidance System is designed for use with both the 7000 and 8000 series of our tractors. The systems are identical on both tractors, whether they are installed in the factory or at a dealership. Maintenance in either case is completely covered by the John Deere Dealer Service System. Before we go into detail on how the Row Track Guidance System works, let's take a moment to look at what it can do for you. This fully integrated row guidance system will give you precision control of integral or mounted implements that you are operating in row crops. It will allow you to cultivate at higher speeds with less stress and fatigue, because you won't have to be constantly looking back to see if you're digging up your crop. It keeps planters on top of ridges and beds, enables narrower banding of herbicides to lower chemical costs, and eliminates guess rows, because row track guidance will keep you on track. Now let's see how row track works. What John Deere means by row guidance is that we have a fully integrated quick coupler with implement steering capabilities. In other words, we have a system in which the implement steers itself. There are two primary types of row guidance systems in the industry: the push type and the pivot type. With the push system, the sway blocks must be installed, locking the three-point hitch in a rigid position. This type of row guidance method then pushes the implement to one side or the other to keep it on track with the rows. In short, it relies on the weight of the tractor to serve as an anchor for stability during operation. With heavy implements, this system has a tendency to make tractor steering more unstable, as well as putting a strain on the implement itself. The Row Track Guidance System from John Deere works on a different principle. The sway blocks are removed and placed in their stored position, allowing lateral movement of the hitch. This lateral movement, coupled with the pivoting action of the quick coupler, is what keeps the implement in the row. So, for all practical purposes, as we mentioned a moment ago, the implement steers itself, rather than forcibly pushing it from side to side, as done by the other system. As a result, you can handle the tracking of even large implements without them pushing your tractor to one side or the other. Pivot systems do require that the implement being guided be directional. In other words, when the hitch and coupler pivot, the implement will immediately steer left or right to follow. For example, no-till cultivators are considered directional because of their rigid trash coulters positioned between each row, which keep them on track. Some implements will require the addition of stabilizing coulters. One example is a conventional cultivator, like this. Another is a bedder. And a third example is a planter without conservation tillage attachments. Stabilizing coulters give implements stability and directionality to hold them on the row. Stabilizers must be mounted perpendicular to the main beam and run at sufficient depth for the implement to follow the row. Now, let's take a few moments to examine the components in a row track guidance system. Most of them are common to both the 7000 and 8000 series tractors. This includes the quick coupler, either category 3 or 3N, which is the narrow version. Both of these are permanent full-service quick couplers. To use these quick couplers for regular duty, just insert the pivot lock pins and remove the row sensor module. The sensor module with independent sensor lift receives data from one of three types of sensors. Guide rods or wands are used to sense standing crop. Inline furrow probes are used to sense planter markers or remarkers. And finally, ridge or bed probes are used to guide your implements in ridge or bed planted crops. Signals from the sensors go back to the controller and are displayed on the monitor in the cab. By the way, these monitors are identical on both the 7000 and 8000 series tractors. However, there are some differences between the row track systems on these two series of tractors. The 7000 has a dedicated row track valve, while the 8000 uses the fourth SCV as the row track system's control valve. However, this SCV can be used to control any other hydraulic functions when it isn't being used for the row track system. The 7000 series has a separate controller for the row track system. On the other hand, the control function for the 8000 series is built into the tractor's fourth and fifth SCV controller. The control panel has a mode selector control with four primary positions: off, manual, active, and test. The panel also allows you to adjust the response rate control and position control. It has a display to allow you to monitor all functions, and also has onboard diagnostics capabilities. To convert your tractor from the standard quick coupler to the row track guidance mode, you will need to make a few minor adjustments. If you have an 8000 series tractor, you will need to remove your drawbar. But if you have a 7000 tractor, move the drawbar to its shortest position and swing it over to the side. With either the 7 or 8000, move the sway blocks to their upper storage position. Now install the row sensor module and its harness. The sensor module must be bolted to the quick coupler, and the harness should be routed and connected to your tractor. If you have a 7000 tractor, make sure the hoses are installed in the valve provided for row track. If you have an 8000, insert the hoses in the number 4 SCV, with the left hose to the left coupler port and the right to the right port. The pivot lock pins must also be removed and inserted in their storage holes. The final installation is of the sensors themselves, along with a preliminary adjustment, as described in your operator's manual. Next, you should confirm that your system is working properly before attaching the implement. First, move the mode switch from off to manual. Then use the position knob to center the coupler. When the coupler is centered, the LCD display will show one centered bar. If it is off-center, additional bars on the left or right of center will show you where the coupler is positioned relative to center. Second, move the mode switch on the panel to test. Move the sensor to the right and then to the left to make sure the quick coupler is responding to the sensor. The coupler should pivot in both directions. The monitor display will show crop indicators. meaning that the row sensor module has been enabled. Here's an important point to keep in mind. The test mode is only functional when your tractor is not moving. During field operation, you will need to use the active mode, which only functions when the tractor is moving. Once you are through with your testing of the guidance system, return the mode switch to manual. And finally, with the mode switch in the manual position, the row track system races the sensors out of the way so they won't be damaged when backing up to an implement. Next, field operation. To begin with, move the mode switch to active and start with both the position and response knobs at 12 o'clock or mid-range. Lower your implement to the working depth and check for proper positioning on your row track sensor readout. Adjust it if you need to. Complete instructions for adjustment are included in your manual. The response knob is used to increase or decrease the speed with which the row track system will respond. In most conditions, the faster your ground speed, the quicker you will want the row track response to be. Once you've made your settings, take a short trial run through your field and make any final adjustments. The row track system is also designed to automatically center the hitch when it's raised. So, you will always start out with your system centered after you make a headland turn. Here's another special feature that will help you keep on track during operation. If the guidance system has pivoted the implement as far as it can to adjust for position and has reached its maximum, a crop symbol on the display will flash and an audible alarm will sound to warn you. The bars on the display will also show you your position, so you can adjust your steering to bring your tractor back on track. If the row sensor module is not exactly centered on the row it is sensing, the system could cause your implement to run too far right or left of the row. This can happen on steep hillsides or in contours. You can compensate for these situations by using the position knob to temporarily offset the guidance system until you return to normal terrain. Here's another use of the row track system, which can be very handy when hooking up to a mounted implement. Let's say that you have backed up to an implement and the 3 points are lined up, but the angle of the quick coupler relative to the toolbar is off. Just switch to manual and use the position knob to help pivot the coupler into alignment with the toolbar for hookup. The row track system also allows you to temporarily deactivate the system while you are operating in an area with no crop for it to probe. All you have to do is move the mode switch to the manual position. Then, once you re-enter the cropping area, you can reactivate the system by simply moving the mode switch back to the active position. And finally, let's take a brief look at the attachments that are available with the row track guidance system. To begin with, there are guide rods used for sensing row crops. A good example of their use would be during cultivation after the crop is several inches tall. Triple ball ridge probes are used to keep planters or spray equipment centered on top of beds or ridges. Double ball inline furrow probes sense furrows made by row markers. These are used to sense furrows during bedding and planting. There are also several implement attachments for the row track system. They include double disc row markers for bedding and planting. These markers create a sharper, more well-defined furrow, making it easier for the inline furrow probes to follow them. Furrow remarkers can also be a big help for cultivating shortly after planting. They redefine the row marker groove so you can use RowTrack with an inline furrow probe to cultivate or spray before the crop is large enough to be sensed by the guide rods. If you have any questions about the RowTrack guidance system from John Deere, please contact your local dealership. They'll be glad to help you in any way they can. As with any of your equipment, periodic preventive maintenance is the key to a successful operation. Refer to your operator's manual for details. And thanks for watching.